So I'm going to talk to you about anticipating technology change, which is clearly an important part of innovation. My definition of innovation is the successful exploitation of ideas. And innovation takes place in a marketplace. And I've looked at innovation in a lot of small and medium-sized companies. And common features in all of the successful ones is, first of all, you need the systems, both informal and formal, in the company to create the innovations. It has to be connected to the marketplace. It has to be connected to the customers. But actually, particularly in small companies, this thing about inspiring, in nearly all small companies in terms of innovation, there's somebody there who feels passionate about it and creates that environment and drives it forward. And that's a very common feature in terms of innovation in smaller companies. So why do you need to think about the future when you're doing innovation? Well, as you go further ahead, the things that you understand, the things that can be modelled or predetermined get less and less, and the uncertainties get greater. So if you're dealing with near-term things, current data, models and so on are fine. But as you get further ahead, these uncertainties increase. And foresight, thinking about the future, is all about understanding those uncertainties. They're still uncertain. You can't magic them away. But it's about understanding what could be going on here and how that can create opportunities for you in terms of the future. In terms of technology, you also need to think about the environment it's in. All these other factors are very closely related to technology as part of it. But what's the big difference between technology and all these other changes? Any ideas? What's happening to change in technology that's different from these other things? I think the key difference with technology is that actually the change in technology is exponential. It's growing faster and faster. All these others, the change tends to be either incremental or cyclical. And so technology has a very different characteristic to all of the others. When I first started doing science and mathematical modelling, the largest mainframe computer had the processing power of an iPhone 4 today. But if you wanted to buy that same computer today, how much do you think it would cost? How many euros would it cost in today's money to buy that computer then? Guesses? No? Much more than that. It's 30 million euros to buy that same computer that has the processing power of an iPhone. So technology is moving faster and faster. About 100 years ago, it was estimated that the stock of human knowledge doubled in about 100 years. There are a wide range of estimates of how quickly it is doubling now, and they sort of range from between about a year and 15 days, depending on how you look at it. So it's moving extremely quickly. Which is another reason why it's important to think about the future when you're looking at technology. A good way of looking at it is to think in different horizons. So if you're here, what you're looking at is the weak signals for emerging trends, the things that are going to be important at some time in the future. And this is where the visionary people are operating. it's also actually where a lot of government investment goes, both in terms of basic research, but also in products. Patrick was putting up the iPhone, but a lot of the innovations that are actually part of that are things like GPS, touchscreens, the internet, and so on. Those all came out of publicly funded programs. So around this area, you've got the visionary people, but also a lot of the sort of basic research, a lot of which is in either large companies or public laboratories. You then get the next, where you have the emerging trends that are becoming much more visible. And this is where a lot of the innovation goes on. And then obviously finally you have the things that are everyday here and now. But if you're operating up here, you're really at the sort of the top of the S-curve in terms of mature technology. So 3D printing has already been mentioned, and how's that sort of gone through these time horizons? Well, the origins of it probably go back to the mid-1980s with the patents for stereolithography, which was the sort of the early start of the thinking around that. And then it became into that sort of second phase when people started developing patents about 3D printing, and you started to see some of the machines coming onto the market. And now you're getting to the situation where there are products coming onto the market from 3D printing, and last year the first jet engine that had 3D printed turbine blades actually was tested. It's not yet in service on a plane, but it's getting there. So some examples of it. There's a machine rather like that outside that you can see, and it's being used in all sorts of novel ways in terms of fashion. This is interesting in terms of a car. 50% of that is produced by 3D printing. And what do you think the advantages of 3D printing are in producing a car? Yes? Other advantages? Sorry? Yes? Yeah. It also saves a tremendous amount of weight, because you can design it very specifically for the various stresses and strains it's going to take, and you can build in very light crash protection zones and all those sorts of things. But I talked about the three horizons. Another factor that's important, and sorry, you probably can't read these, and I'll give you some examples in a moment, is actually the hype cycle, which happens in most technologies. Probably the most famous example of the hype cycle is the dot-com bust that occurred at the turn of the last century. But to give some examples here, 3D printing is probably up here at the moment in terms of hype, and whether it's going to have a big market in fashion or fashion's going to go down here, who's to say? But that's an example of something that's up at the top of the cycle. Things down here are things like sort of quantum computing, and you've got human augmentation. And up here you've got mature technologies. Speech recognition, for example, is one of the things up there. And that's a very typical cycle. So if you're thinking about technology, think about the time horizons, but also think about the hype cycle. I remember meeting, Amazon's come up already, I remember meeting Jeff Bezos when he came over to the UK looking to invest in terms of European distribution. And at that time they were sort of down there, and it was all seen as high risk, and everybody was saying you shouldn't invest in this. And the share price was about $10 then. After about 18 months, 2 years, their share price was over $100. And so people were saying, well, perhaps we should have invested. But actually, although it was successful, it still went through a similar sort of cycle, because after another couple of years, their share price had dropped down to $7. But as we know, they've been very successful, and I think they're currently trading at about $400. So that's an example of a company that's been through that typical sort of cycle. So I'd now like to talk about a few of the disruptive technology trends. And this is not an exhaustive list, and if you ask somebody else, they'd probably come up with a different list. It's really just to get you thinking about some of the things that are going on in the technology sphere that are going to have a big impact. And I've already mentioned that one of the key things in technology is the rapid increase in knowledge. So, if you're an undergraduate at university, some of the things that you're taught in your first year now are likely to be overtaken by developments by the time you graduate. And Patrick mentioned about investing in your people. You've got to keep investing them so they understand how technology is moving and the opportunities that creates. Another big trend in technology is the converging technology in terms of the applications of technologies and how they come into the market. Who can think of something which is a highly converged technology? What's an example of where technologies have come together? Yes? Yeah? You can now, and in the bio area, another sort of example of converging technologies, biocomputing, where the IT and the biological world have come together. And that's a trend I suggest that we're going to see more and more of. Another big trend is doing it mobile. When I was young, about the only thing you could do mobile was listen to the radio with a big box with heavy batteries in it. Now you can do anything anywhere. We have sort of ubiquitous access to virtually anything, and the people couldn't have imagined things like banking through a mobile phone. They wouldn't even thought of a mobile phone in that time. So doing it mobile is now a ubiquitous trend. Another one which is probably more modern, more recent than that, is actually letting machines decide. Who can think of some examples now of where machines are making decisions for us? Yes? Sorry? Smart houses, yes. Any others? Sorry? Yes? I think the one area where it's actually now got to the point where humans can't make the decisions, even if they wanted to, is automated stock trading, because it happens so fast that people just aren't quick enough to compete with the machines. But and I think self-drive cars and so on. So we're getting to a stage where that machines are deciding for us, which in some ways is linked to the whole question of brain enhancement. There was a study done in the UK recently for students, asking whether they'd use cognitive enhancing drugs to help their performance. What percentage of students do you think have actually used drugs to help their performance? It was actually 25% who admitted to it. So what the real percentage is a moot point. What percentage of those that had used them do you think would say they would use them regularly in the future? It was in the high 90s. So that's just one example of brain enhancement. But there have already been experiments successfully transmitting from one brain to another, so getting brains to communicate automatically. And I'm sure in the future we'll see brain implants, brain enhancement. So there's some really interesting things going on around us and machines and the interface between them. And I think that we're only just starting to see the tip of the iceberg in terms of that, which also links in with the automation of knowledge work. That about 27% of the people working are in what one would classify knowledge work, and Gartner have done an estimate in terms of the potential impact of effectively automation of those jobs, and by 2025 they estimate the economic impact of automation knowledge work will be about 5 trillion euros. So that's a big business that's going on there. So that's just some example of some of the technology trends that are happening. And in terms of technologies themselves, next generation genomics are going to have huge impacts in areas, particularly health and agriculture. Robots and cobots. Cobots are collaborative robots that work with people. And I'll say a little bit more about those in a moment. I've already spoken about 3D printing and the application of those, but how many toys do you think are produced every year? Worldwide? It's 8 billion toys are manufactured every year. And what proportion of those could be made by 3D printing? And what would that do to the business models and the value chains? What would you think about that if you were sitting in China at the moment? Another interesting one is energy storage. That has an impact across great ranges of technologies, both at high levels and low levels. And there's also a trend that has a big impact both in terms of the developed countries and the developing countries. The Internet of Things, ubiquitous connectivity, that's growing extremely fast. The cost of the technology for this is reduced by 90% over the last 5 years, and there's no sign that that's slowing up. And advanced materials. An example I like in advanced materials is you can now get materials that when you stretch them, they get fatter, which completely changes the whole properties of how things behave. So they get stronger when you put them under tension. They're really good if you compress them. They're very good for protective clothing, for crash protection, and so on. So you're seeing all sorts of materials, and that changed the laws of physics, because until the late 80s, when people started looking at materials, if you studied physics, you were told that actually you couldn't get a material that when you stretch it, it got fatter. That the relationship's called the Poisson ratio, and it was something that you could never actually quite get to zero. So those are some technologies, and obviously there are many more that are completely changing. Now, I talked about cobots, but if you asked until recently what a robot was, they would think of things like this that are doing repeat tasks, often operating in a hazardous environment, difficult to program, generally quite expensive, and a lot of them work in cages. But why not have robots that are cost-effective for non-repetitive tasks, that are easy to program, that can learn on the job, can work safely with people? And actually, these things now exist. But 2 years ago, I was doing some work with the European Programme of Advanced Manufacturing, and the consensus was that this will never happen. You won't have robots working with people. So how do you think about things that are happening in the future? And looking at technology, the traditional thing was horizon scanning in terms of sort of focused review, and collaborative approaches using things like Delphi and so on. But you need to be careful with that, because Delphi processes tend to come back to a consensus, and that can squeeze out some of the innovative ideas. There's now software you can use to look at that, and obviously social media and things like gamification, and Stefan talked about some of these sort of crowd type approaches. Another approach is scenario planning. We did a project across Europe looking at green jobs, particularly the hazards from those, and that looked at a number of 26 key technologies, and it was all about creating a dialogue between different sectors, between the manufacturers, employers, people engaged in research, and so on. And that led to a number of issues that emerged. And I think the key point from that is they can form an environment where people can use them as a laboratory for thinking about potential ideas, testing them against different futures. So, by way of conclusion, what are the sorts of things that you should be thinking about when you're looking at technology for innovation? First of all, beware of the illusion of certainty. I'm sure we all have our favorite technology quote. There's a lot of them around IT about things. For example, Ken Olsen, who was with Dell when he was talking to the World Futures Forum, said there's no reason for any individual to have a computer in his home. Probably in the future he'll be right, but he probably wasn't right at that stage. Foresight is important for thinking about the future, and how technology takes a part of that. And it's really important because you can't predict the future. to test your plans against a range of different assumptions. Also, don't forget to look backwards to see what's emerging. Look at the interface between sectors, and also the ideas don't always come from where you expect them to be. And if you're leading innovation, I think the two important things I'd like to finish with is, first of all, think about what questions you're going to ask and make it fun. Thank you.